So let's start our next section, which is 3.5, and it's about implicit differentiation. So most of the functions that you've encountered previously have been explicitly written. So let's look at an example. So for example, maybe the function y equals 3x squared minus 5. That's an explicitly written function, but not all functions are like this. And so I'll say, but some functions are implicitly written. So I'll give you an example here as well. So for example, x times y equals 1. Now this is a implicitly written function. We could write it explicitly by solving for y. Y equals 1 over x. And then, once we have it explicitly written, we could find the derivative as well. So the derivative, y prime, would be negative x to the negative second if we use the power rule. So that's great, but sometimes we can't write functions explicitly. So I'll say sometimes you cannot solve for the function explicitly. So let me give you an example here of a function you can't solve for explicitly. So x squared minus 2y cubed plus 4y equals 2. I can't solve for y here and write it solely in terms of x. So then the question becomes, so I'll ask this question. We want to know, how do we find the derivative in this case? I can't solve for the function explicitly, but I still want to be able to talk about the derivative. And so the answer is to use what's called implicit differentiation. So we're going to look at implicit differentiation through a few examples. So let's look at our first one. We want to take the derivative of y cubed. Now secretly inside of this y, there's x's there secretly. We just don't know what it is. And so we're going to have to use the chain rule here. And the chain rule would say you do the power rule first on this exponent. So 3y squared. But then I have to take the derivative of y, so that would be dy dx. Let's look at another example. So let's say I want to take the derivative of x plus 3y. Well, we know the derivative of x, using the power rule, the derivative of x is just 1. And then here, the derivative of 3y will be 3, but because we have a y, it's going to be 3 dy dx. And then our third example, on the derivative of x times y squared. Now here we need to use a product rule because I have two things being multiplied, an x and a y squared. So let's start with the product rule. Copy the first one down, x, the derivative of y squared, plus copy y squared down, the derivative of x, the derivative of y squared, it's 2y dy dx, plus y squared, the derivative of x is just 1, so here's my derivative right there. So don't forget that you might have to use your product rule and your quotient rule or your chain rule to help you compute these derivatives here.